Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hey guys, as you know, I'm Nick.
Hey, I'm John.
And we're actually here at Rapid+TCT 2023. And you kind of hear some of the noise in the background. And, we're kind of doing a company spotlight, on Ulendo. And we are here with Ms. Brenda Jones talking about Ulendo. And what is your background? And why don't you introduce yourself to everybody?
Yeah, my career has been mostly in software, usually CIO or VP of Vice President of Professional Services. But about 7 years ago, I transitioned into entrepreneurship and decided that I wanted to try a different track. So I started to get involved into the entrepreneurial ecosystem in southeastern Michigan. Joined up with a couple of startups, did a little, volunteer work for them. And in 2017, I actually ran into a company that had developed a piece of software on the campus of the University of Michigan. It was a computer vision-based piece of software. And that's pretty much all they had. They had no website, no logo, no nothing. And we took that company from just the idea on the college campus all the way to selling the company in 3.5 years.
Oh, wow.
Yeah, that's
awesome.
super quick.
That's impressive.
Super quick.
Yeah.
We did it all bootstrapped, so hadn't even taken on any investment. So after I completed that, did my wind down, usually the CEO, they don't need two CEOs, so I wind down and do a transition. I decided to volunteer for a class at the University of Michigan's Business School. This is a really unique class where they take local startups as the subject matter of the class, and they put groups of students, they assign groups of students to each one, and they learn about being a venture capitalist. They also learn about what it feels like to ask for money as an entrepreneur. So it was in that class that I met Ulendo, the founder and the COO of Ulendo. And I was just so impressed by their technology. They had patented it. And the two guys that had started the company were great. I thought we had a good, chemistry match, which is important it's really important when you're starting a company. So about a year ago, I joined them as their CEO. It was at last year's Rapid, actually in Detroit, that we announced the commercial availability of our first product. So that's how I got, essentially software 7 years ago, transitioned to entrepreneurship, and now that's my thing, is identifying academic-based innovations and bringing them to market.
That's awesome. That's absolutely awesome.
That's actually perfect because that kind of segues right into the next part, which is exactly what the mission of the podcast is STEM education and kind of growing in that mindset, because we, personally, I didn't see my first 3D printer or know about additive manufacturing until about my senior year, which is about 2015. So at that time, it was pretty expensive to kind of, the barrier to entry was very high cost. So, and of course, you got to convince people that this is going to be a viable solution. You're not just doing it for rapid prototyping. You can have products that are, manufactured in the sense that are full production, pieces and parts.
Yep.
So if I'm able, or if we're able to kind of, with the podcast, get the information out to, kids in 5th or 6th grade, if I had gotten it in 5th or 6th grade, the trajectory of my, college career, where I would have went to college, what I would have studied would have vastly changed. So that's something that it's kind of a linchpin or sticking point for us, is we need to get not just, tell people about 3D printing, but get the printers into the classrooms and kind of show instead of just telling. If we put something in the hands that shows maybe a physics property, we can teach somebody how it works. You put that in someone's hand, that's going to get the gears kind of moving. So that's exactly what we would like to do. And honestly, seeing some of the products that Ulendo, the software Ulendo offers is really impressive in just the amount of time, because you think about prints are 6 to 7 hours if you want something substantial. So being able to cut down time, or being able to get it done in maybe 1 day versus 2 days is something that's vital and will increase that visibility. So definitely what we like to do with the podcast. So.
Well, so education is part of our cultural values as well. We, of course, our founder is a professor of mechanical engineering at the University of Michigan, Chinedum Okwadere. We call him Chi for short. So he, as a professor, is always mentoring, master's students and PhD students. But from the company's perspective, we also support education in multiple ways. We almost always have an intern, even working with us, sometimes multiple interns. Even though we're a small company, we feel so strongly about making sure there are more people that understand additive manufacturing and this kind of technology with a hands-on approach. That's much better.
It's kind of funny when we kind of we started segueing into especially like the education side of the house. It's because he calls me insane, which is fine. I'm not going to disagree with this.
A little crazy.
I'm trying to I've been telling him for the past year, you need to go back to school. At least get your master's degree out of the way.
Yeah.
So it was pushing him towards the additive manufacturing program at Penn State.
Yeah, I'm gonna.
I applied there. But you, of course.
Yeah, I have. So my background is in physics actually. So I went to school. I went to University of North Carolina at Wilmington and did the physics undergrad, and it changed how I thought. So high school, they never teach a lot of the students kind of skills to grow in your career or past high school. They're just trying to get you to the next grade or to graduation so you can be someone else's problem, right? So if you're not doing some of this stuff on your own or you have outside, influences on the students, then you end up not getting that growth and you lose a lot of time. So I did, when I went into physics, I didn't go in just because I was curious about how things worked. It was, I wanted a challenge, and it definitely was a challenge, but we made it through, and at the end of the day, I do need to go back, and I am going to go to Penn State for the additive manufacturing, Masters of Engineering with focus on additive manufacturing, and in that sense, I want to bring a lot of the knowledge from that class to, of course, the podcast, and of course, to kind of the area around South Carolina, because not a lot of companies they're kind of dabbling in 3D printing, but I don't think they've kind of taken the full dive in. So they have small things, they do rapid prototyping, but a lot of those things aren't as rapid as they would like them to be, because then they have to send it out to get it machined and actual metal parts. We don't have some of those things, so the process it needs some work.
Yep.
So especially with a global company or any global companies, to get everybody on the same page, it takes even more work. So that's something that we're going to do, and of course, because he was the one that kind of started me on that path, because he's going to get the doctorate in technology.
I start next month for the doctorate of technology program at Purdue.
That's why I call him crazy.
Oh,
It's a lot of
focusing mostly on the additive manufacturing side of the house. But also, for me, and I know it kind of segues into the software side of the house, is how do we secure these things? How do we secure a 3D printer? Because your USB port on a 3D printer is the segue into your network if those printers are networked.
Yeah, right.
So, for me, it's kind of like looking at the cybersecurity side of the house, when it happens. But for me, it's also, how do we take additive manufacturing and use it for the educational side of the house? I have friends who are teachers.
Yep.
And they don't have printers in their classrooms. The only printer they have in their classroom is at the library where they make, bookmarks.
Very underutilized.
Yeah.
A lot of opportunity for growth.
Exactly.
So to reflect back on what you were saying about, the speed, so one of the issues that with the adoption of additive manufacturing, the reason why it's been so slow is that it suffers from quality and speed issues. And some of those quality and speed issues, the underlying problem is the vibration. So as you probably know, when you try to operate a 3D printer too fast, it starts to vibrate, which creates surface defects, and it can be as bad as, spaghetti. You end up with a spaghetti part, just layer shifts, and it's just all messed up. Wasted time, wasted material. So that's what our first product does, Ulendo VC, vibration compensation. We actually compensate for the vibration on a printer so that it can run at twice the speed with the same quality.
That's awesome.
And this is entirely software based, so you don't need to add any particular part or change a motor or anything, you can do this with, your OEM printer if you want, right? So that's actually what we're going to get into next, because that issue, we see it now just with the with the consumer grade printers like your Ender 3s and your Prusa and things like that. You see, once you start cranking up some of the speed, if you change some of the firmware, the firmware will make the print appear to print faster. However, you're going to get the artifacting like you were speaking with, and honestly, if it's a product of the system. So Core XY or standard, I think it's Core YZ or something like that, or YX. They don't compensate for that, and honestly, they don't have any stabilizers. It's because you want to get the price down, you want to get it in everybody's rooms, everybody's home. So they take away a lot of that, and if you can solve that with software, that's game changing, And to kind of piggyback on that, I saw some of the pictures of the prints, and I definitely have some prints that are spaghetti, because I tried to. We built a couple Voron printers, which is kind of it was a passion project, right? So it wasn't anything that like we were trying to kind of show off or anything, but it's something we noticed is the Voron is trying to print faster. It's using the Core XY system. However, there's still issues with a little bit of the vibration. It's trying to go faster because with the Clipper firmware, it pushes that a little further. So I think we were mentioning it last time. Your software, does it go down into the firmware? Is it a configuration file? Or it's just or is it a slicer in and of itself?
It's neither of those.
Okay.
So there's actually two steps.
Okay.
The first step does require an accelerometer. So we slap an accelerometer onto a specific printer. Let's say a printer model. Let's talk about the situation where a manufacturer wants to make their printer model Ulendo enabled for their end users.
Okay.
So we slap an accelerometer on that. We run it through some motions, and we basically collect enough data to characterize the way the printer is going to vibrate. We turn that into a calibration map that we store onto the controller of the printer, along with some of our other software, alongside the firmware. So it doesn't replace the firmware; it's integrated with the firmware.
Okay.
So then every time, then you take the accelerometer off. You don't need that anymore. Now, when you operate the printer, now we can predict when the vibration is going to happen, and we trick the tool path into going in the correct direction, so as to avoid the ringing or the the quality problems that you see.
A little dissonance and stuff like that.
Yep. Mm-hmm.
Yeah, no, that's really impressive, because that's the first thing that I noticed with my printer, where I didn't do really much to it. And whenever I tried to crank, it gives you the option to crank the speed up. I tried to crank the speed up, and it starts whining and complaining pretty much. So that's definitely an issue. So you're saying it works in conjunction with the firmware. Does it matter which firmware it works with, or is it compatible with? I mean, I know Marlin is kind of a child or a product of RepRap. And Clipper also is uses like a Marlin base for their thing. So I'm assuming a lot of those probably work together, right? So is there? You guys don't work together with any of the firmware? I guess the GitHub, the firmware repositories or anything like that. You can just introduce it in. You don't have to look with just the accelerometer. It's all you need. You don't need any of the other configurations. Or it does it by itself, I mean.
It does it by itself.
That's pretty impressive.
Yeah. So we would be able to implement our software on a controller with any firmware. It's a matter of how difficult it is. So we have the most experience with Marlin. We also have experience with Sailfish. So as we do additional customers who have used different firmware, we'll get more and more experience with different firmwares. Okay. The most difficult situation is when someone's developed their own piece of firmware, or that it's on a closed controller that doesn't have a lot of documentation. So that's the most complicated implementation.
I guess the question I was trying to get to was the support for that. So if someone came to you with a more custom firmware, would it be still able to?
Yep.
So you guys have a team that works together?
Yep.
Oh, wow.
That is awesome.
That's impressive.
And for example, I run with my Voron. I've got a input shaper on there. Mm-hmm. It's permanently affixed to the back of the back of the device because everything's running CAN bus. But I'm also running Clipper.
Yes.
So if I switch that over to which it might be really interesting to run Marlin on a Voron, changed my mind. So I can actually
possible.
install
Why
it.
can't you?
Yeah,
It's
true.
possible,
I can
yeah.
actually install it on that same. Oh wow. Okay.
You could try it out. Yeah, I mean,
that might be an interesting install.
no, yeah, because that, when I was doing a
I know
little
they
bit
used to run it on Warren. That'd be actually really cool.
Well, no, it's worth a try. I mean,
Yeah.
honestly, at the
I
end of the
got
day,
enough
you
printers now to figure something
just save the old configuration if you need to revert back. But
Yeah.
that's kind of what I was getting at. Is like, what's stopping us from trying it, right? And there's nothing really. That was, the support for it. As long as the support's there, like working together. Because one of our friends that works with us, he definitely he's on the contributor page for Marlin firmware on the GitHub. So we definitely have somebody that a little bit more knowledgeable in the details of the firmware than us. But it's something that all of us are interested in. So.
And is it able to be pulled up off of GitHub, or is it directly from the Ulendo site? How do people get their hands on it?
So I will answer that by talking about our contribution to Marlin, the
Awesome.
Marlin open source.
Okay.
I'll string
Yeah,
those
that's
together.
something that we're interested in is the open source.
Yeah,
was the
I'll
next-
string that
yeah.
together. So let me first talk about Clipper. So Clipper, we've noticed a lot of attention in the past, say, 6 months or so about Clipper's input shaping. That's a software approach to vibration compensation as well. However, according to my understanding, at least now, you still need an additional device to run Clipper. And input shaping, because of the technology, the way it works, it results in rounded corners. So that is going to be an issue for an industrial user. It may be perfectly fine for a home user, an enthusiast might be just perfectly fine. But rounded corners, as you can imagine, would not be satisfactory for a high precision part that a manufacturer wants to make. So we saw all that going on, and we said, man, why don't we had developed our own input shaper ourselves, just to compare our technology to input shaping as a technology. So we decided last year to contribute our input shaping code to the Marlin open source project. So that's in there. It's called Fixed Time. And now when you download the latest version of Marlin, you can actually use input shaping if you want. You can actually now, we've opened up, because of the way we implemented it, you can attach other advanced algorithms to our fixed time component. And if you need the increased precision of the Ulendo VC solution, there's a fast upgrade track that you can follow right from the Marlin firmware to upgrade to our commercial product.
Oh, wow.
So it's a nice, easy path. We're hoping to then do the same thing with RepRap and other commonly used firmwares to make it as easy as possible for folks to implement our stuff.
Yeah, so that's the next question, or the next step that we wanted to go over was the open source availability. So if it's easier for the masses to get a hold of it, then it's easier for us to teach it to any classrooms, or get it in any environment where the kids can kind of mess around with it, play with it, see the capabilities that they can kind of utilize with it. So
now, I know, as we're talking about open source leads me right into that NSF topic. The National Science Foundation grant that y'all got.
Yep.
That is the mission of that grant is for what?
Yeah, so the specific grant that we won was a grant that's given to small companies, early stage companies, that are trying to advance a technology that has some technical risk to it, and they're trying to bring it to the market to change the world.
That is awesome.
There's a phase 1 and there's a phase 2. So the phase 1 is a shorter project, like a 6-month project or a year project. We won that one in 2021. We completed that project. That was for $250,000. Then we applied for the phase 2, which is $1 million, and we just got awarded that. We got the approval for that about 6 weeks ago.
congrats, yeah.
So the purpose of the grant, of the work on the grant, is to increase the accuracy of our algorithm, because there are still use cases that it doesn't handle. And that's very typical of academic innovation.
Right.
You do something in the lab, and until you put it out into the wild, into the real
don't find out
world,
how to use
you don't
it.
find out those things. Right.
Stress tests, yeah.
And we're expanding the way that it works. I mean, we initially came up with it to implement at the manufacturers of 3D printers. Now we're making changes to it in order to enable it to do the aftermarket, so to be installed after somebody has already purchased the printer, they've been using it already. So it's a combination of, it's basically advancing the use of vibration compensation in 3D printing.
That is awesome.
Yeah, no, it's really impressive. I mean, honestly,
Yeah, exactly.
So phase 2, you said you got that this year.
Yep.
How long is that?
That's a
project?
2-year project.
Oh wow, that's
Yep.
much longer.
Yeah.
But it gives you a lot more time, time to kind of work on any of those issues, of course, and get like we were speaking about before, be able to have time to think about how to integrate into a more consumer, the consumer side of the house, the hobbyist side of the house, because a lot of the printers, like I have a whole lot of friends I went to college with that just bought their first printer.
Yep.
They have so many questions, and I don't have enough time to explain everything.
Right.
I got to get them all into one room so that I can have like a little press conference with them. But no, I see that. So I see that you brought a print here. I know that we can't really show, but I'm going to put on our social medias kind of the comparison of the standard print with the ones using Ulendo software.
Well, this is actually a piece that's quite different. This shows in one part, and I'll try to explain it because I know everyone can't see this. This in one part we show the effect of our software. So this was printed on an industrial 3D printer, and we printed it in three pieces, so 3 stages, but all one continuous part. First, we started with the stock firmware at a normal speed, so it's good quality. Then we sped up the printer, and now you can see ringing. And if you run your fingers across the center third, you can feel the ringing, right?
Oh, okay, yeah.
Then we stopped the printer, installed our software on the controller at that same speed as the ringing. Now feel that one. That's awesome. All the ringing's gone, and in fact, now compare it to the stock firmware. It's even better than that.
Yeah, it's even better.
This was a surprise to us. We actually improved the quality of the print. Not only did we double the speed, we improved the quality of the print as well.
Yeah, that's
because
awesome.
you can even see you were speaking about the corners and kind of the precision around the corners. That is a problem. Kind of watching a lot of the prints, I definitely see. And of course here you see it's fused together.
Yep.
Whenever you do some of the, there's a little bit of issue there, and it kind of creates. Eventually, if it continues for too long, the print's too tall, you're going to have a layer separation.
That's right.
And I can even see the degree. I can even see that whenever you install the Ulendo software, the gaps are there where they're supposed to be.
Where they're supposed to be. That's right. Yep.
So if you're trying to print an articulating part, which a lot of the prints are, one print, you don't want to spend too much time if you're making a part, and if it needs to articulate it all. You need those not to be fused together, because then it's the same thing as having a layer separation. So I can even see the corners are exact. So that's a lot of the problems that I still have with my printers. So but yeah, no, it's really impressive.
It's kind of funny because I just remember something. I was thinking about what you were saying earlier, where the input shaper that is given in like Clipper rounds your corners. I was actually making boxes for this trip, so I could put all my thumb drive, my micro SD cards in there, because you got thousands of darn things, and I couldn't fit the damn box together because of the rounded corners.
Because of the rounded corners.
I was thinking about that, and I was like, she's right.
And that could be fine. And guys, that could be fine for a lot of users. But when you get to the industrial market, that's just not going to fly.
Yeah. And that is exactly right. And it's like, and that's, you want, it's like, for me, I like the high precision prints like that. I like to be able to come to a show with something I can actually put together and use when I'm here.
Yeah.
And that's stuff that I now have sitting in a bin someplace that's going to hopefully be eventually recycled.
That's something that we're going to get to eventually is the sustainability side of the house as well, because this is kind of indirectly solving a lot of those issues.
Yes, it
right?
does.
So
yes.
I don't have to print this 5 times, right?
Yep.
And not even just that. Like I think we talked about the timing and the speed of the print. So being able to cut print time down while maintaining quality is it's a win-win. And to be honest with you, it's a no-brainer. Why would you not want to do that?
Right.
So
It's less scrap.
yeah, less scrap. And
less scrap.
At the end
and
of
there's
the day,
something else too. There's something else. What 3D printer manufacturers sometimes do to reduce vibration is they make the printer heavier, so that means more metal, that means more cost. Or they put expensive controllers in there, again, more cost. And that whole thing, because it's heavier, now it uses more electricity, more energy. So there's lots of little kind of indirect spots where our technology actually reduces waste and improves energy efficiency.
Yeah, exactly. So it's solving, and it's crazy because you're not adding any hardware.
Right.
You're actually allowing for removal of a lot of those extra, counterweights and things like that. And you're solving it with, a software-based solution that, we get to the open source where you were speaking on Marlin and having fixed time and adding it, being able to bring it to the commercial side. You're definitely allowing a lot of people to be able to have that access. So
it makes additive manufacturing more available to your lower level suppliers, your low level manufacturers, the new guys coming on board, because they can get an Ender 3 or something like that that's not that expensive, and run the Ulendo software through Marlin.
Yeah.
And it will fix 99.9% of the issues they're having.
You get the consumer side of the house, and you make the quality so high that it's comparable to the industrial prints.
That's what's happening, guys, is there's a convergence between the expensive industrial printers and the features that they have and the quote-unquote desktop printers.
Right.
It's coming together in very interesting ways. And in fact, our first customer is a company that was primarily desktop, and they were coming out with their first industrial printer. So they knew they were going to have to get increased speed and precision. And so we were the answer for them.
Yeah, you can't
That
sacrifice
growth
any quality.
is insane. The growth of the company and your software so far is absolutely insane. I mean, it's fun to listen to because it's like, I'm a software guy. So for me, I kind of see that path, and I'm like, oh, that's really cool. And, I come from a software testing side of the house, too. So I look at it and go, that's fun.
If it can make the process easier, it'll make it quicker to learn. Yeah, and I mean,
And quicker to learn.
yeah, we never stop tinkering, and that's the crazy part. And if it saves time on the side of, I don't have to print this a second or a third time, it gives me more time to tinker.
That's right.
So,
That's right.
Because everybody's a tinker at heart.
Yeah,
And,
yeah. I mean, that's why we're here, right?
Right, exactly.
Yeah.
And if your tinker actually looks better than it did when it first came out the box,
Yeah.
then
You want your print to be something that you're proud of. As
Right,
well.
exactly.
So we can kind of we have like one more topic because I don't want to take too much more time. But
Okay.
so we're talking about we talked about the support and if someone wants to bring like proprietary or custom firmware to the print and being able to adjust for that. The printer support or the future plans for any of those things, those are already in place, but is there anything that you guys are working towards bringing to, not necessarily market? I know that you guys have the phase 2 of the plan to increase your accuracy. Is there any other things that you guys are kind of working on?
Yes. So one thing that we've noticed is that when we can get a printer to go and increase speed, now extrusion problems start to happen. Now the print head can't keep up, the warming of the materials.
Right.
So there are extrusion issues. So we have an extrusion control solution. It's in its nascent stages, but there's something really significant. It's a different kind of 3D printing technology, laser powder bed fusion.
oh yeah,
So in laser powder bed fusion, you have a laser that's, it's got its path. Some paths create a situation where there's a hot spot right next to a cold spot, which in the final part is going to create distortion. So if you can find a way to have a laser path that minimizes the differential, the adjacent differential in the
Right.
heat, you get less distortion. We have a new product coming out, probably at the end of this year, called Ulendo HC, heat compensation. That will modify the laser path to essentially cut that distortion in half. You can't cut it all out, but cutting it in half is pretty good.
Yeah, it's definitely, I mean, when you get into the metals, it's definitely, it's a lot more difficult to kind of work with a lot of those things. But that's really impressive because that was going to be one of my next questions is so you guys are software based. not all materials are made the same. Not all filaments are made the same. Not all metal powders are made the same. They all have different properties. When you try to increase the speed, one of the biggest issues, of course, was that flow rate. So that's exactly what I would like to kind of learn about as well. But we can kind of touch that on a little bit in the future as well. But that's really impressive to me because you guys started with dealing with the more FDM printing and kind of those things. But when you get to laser powder bed fusion, now you're dealing with the industry. You're dealing with a lot of the parts that need to be durable. They need to be used for thousands of hours. Mm-hmm. So being able to print those with any bit of quality and not having to have a machine it or anything like that, you're saving a lot of time again. So,
yeah. And it's again, it goes back to that growth. I think Ulendo is going to be a game changer in the future.
Thank you.
And it still is a game changer right now.
We think so.
It definitely is. And I want to hit when we got the email, by one conversation. I looked at everything. I told him, dude, you got to read this.
Pretty exciting.
You got to read this documentation. I'm like, you're talking about this algorithm they're using, and it's awesome.
That's what I thought when I first saw the technology and their description of it. Jaw-dropping is the word that I use. It was like, you're kidding me. You're kidding me.
I was reading through it the first time. Whoa!
The reason we went to Clipper and the reason that we put all of our printers in and we built the Voron and we went to that direction is because of not just input shipping, it's speeding up everything. And then, but you're absolutely right. I need a Raspberry Pi to be able to kind of work on some of those extra processes where my microcontroller wouldn't be able to kind of keep up. So because a lot of those, they don't have very much processing power. Of course, we were talking about keeping the price low. Means that the chip is going to be very cheap or as cheap as possible. So that's pretty impressive in and of itself. So we're definitely going to be keeping in touch so that we can kind of have
reflashing an Ender when I get home.
Oh yeah,
and get an AXDL so we can do.
I'm not going to hear the end of it. He's going to make me do it. So
and the thing is, we may turn around and do a YouTube video on it, just to kind of show that off.
That would be great.
We'll do some. We'll do a couple prints and we'll compare because that's a fantastic experiment because I was already thinking of doing. I know that you have the prints and having two done at the same time, but we have like multiple Ender 3s, so we can actually put them up in real time and record both of them printing and see what it looks like in real time, so we can show the masses what it feels like or what it looks like. So
we're definitely going to be doing a follow-up episode and having definitely keeping in touch.
No, exactly.
The software is awesome, and we're definitely going to be playing with it. We'll definitely give you our opinion on it. Believe me.
Okay.
Us playing with it, us enjoying it.
Yeah. So
you might not be with a smile off our face. We're really going to do it.
Yeah, and I've got a lot of information I'm going to kind of throw in there. We're going to see what it does and see how the prints come out because, we've got projects we're working on as well, and it's just kind of like, passion projects at the house. Like I want to make a smart mirror. I want to make my own little Kuka robot, just a little tiny one at the house, just because I have all the parts already. But now I don't think I need the Raspberry Pi or anything like that to make these prints more precise. So it's gonna decrease my energy footprint at the house. So I'm excited. I don't want to pay a higher energy bill. We've got seven printers going on there. It's a lot.
Oh yeah.
So, so I think that's all the topics we had.
Yeah, I think that kind of closes it out. And for me, I just everybody that's listening to us, it's a global audience, and we just want to say thank you. Everybody who's tuning in and listening to us. This is one of probably many of the company spotlights we've been doing coming out of this show. And we're definitely going to be keeping in touch. And I say thank you to everybody who listens, everybody who's involved, everybody who wants to be involved, everybody go out there and take a look at Ulendo, take a look at their software and their hardware, be on their fan club because I guarantee you it's going to grow quite rapidly.
Yeah, keep an eye out. Yeah.
So from my side, I say thank you.
And I also always mimic ditto what Nick says. I'm very appreciative. It's nice to have a platform to speak on a lot of these things. It's nice, and I'm very appreciative to Ulendo and Brenda because we didn't ever think that we would be able to even get to this stage and kind of talk with a lot of the companies, and you guys are very down to earth and very understanding and wanting to get the information out there. So having an extra platform, we don't mind helping and it's engaging conversation. So Very appreciative. Thank you so much for joining us.
My pleasure. My pleasure.
Yeah, we'll keep in touch. So.
And if you have any closing words, you're more than welcome.
Well, if anyone hasn't really visited this conference, they should really give it a shot. This conference, Rapid, I think next year it's going to be in California.
Anaheim,
it is an eyeful. They've had a lot of student groups going through the show the past 2 days, and it's been just refreshing to see them learning about brand new technologies.
Right.
Definitely plan on being there next year.
Oh yeah, we will be there.
So, all right, y'all. Y'all have a good one. We appreciate it.
Thanks so much.
All right, bye.
Bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.